So go ahead and please approve recording. And we're getting ready to start. Welcome, everybody. I'm happy to have you all here. Um, I am Dr. Thomas Talbot, and I'm the principal investigator for the Open Medical Chester Project. And I want to welcome you to the debut of OpenMG 2.0, which is our public release and represents the conclusion of the effort. What we're going to do today is we're going to tell you what OpenMG is. We're going to take you through its evolution, and we're going to show you what it's currently able to do. As part of that, we have a couple transition partners, namely Metaimmersive Gaming is our first transition partner, and our second is a team of Geneva Foundation and a company named Exonicus that integrated a simulator developed at Madigan Army Medical Center. You'll have quite a few things to see there, and then we will go ahead. Okay, then we will go ahead and they will provide a couple demo videos that they will share with us, and then we will provide GitHub URL information of how you can integrate OpenMG and make use of this tool. And finally, we'll be open for questions and answers. And if there are questions during the presentation, feel free to chime in. I am going to make David Kwok, who is my one and all support staff at ICT, the Institute for Creative Technologies at the University of Southern California. I'm going to make him my co-host, so he is able to admit new people who show up or handle things in the chat room, that sort of thing that I may not be paying attention to. So he'll be able to address that. So OpenMG started originally. We started back in 2017, and it was a effort under Defense Health Agency through RDECom, which is now DevCom, at the Soldier Training Technology Center in Orlando. And what it was is there was a solicitation asking for better ways to interface with computers and mixed and virtual reality. And we proposed Open Medical Gesture, which is a tool that had a couple goals. First of all, the goal was to be able to use hands naturalistically in virtual environments. Because we felt that the hand controllers and other devices were very clunky, and many of those interactions were not very uniform between devices, and the state of that was not very good. We wanted to take advantage of a variety of new technologies being developed in products. And so OpenMG was based off a universal hand model, which is device independent. So the idea is that we have a schema for your hands and fingers positioned in 3D space that we could apply, machine learning to get an idea what your hands are doing. And the fact that you're using a camera or using gloves or what 3D camera you're using really wasn't important, because you could switch out the devices as you wish, and you could run them in your simulations or games without regard to what the hardware attached to the device is. So that was the idea. And actually OpenMG 1.0, which I'm going to run you through a few demos really quick, was quite a bit different of a vision of what we ended up doing in 2.0. And I'll give you some examples of why that was. So OpenMG 1.0 is actually pictured here in its testing console. You're able to use this console to select different devices. You could actually train new gestures in the system. And it was designed to basically learn new gestures and very specific gestures. So there would be one gesture you would make to have your hands be a scissors, another gesture that you could be a syringe, another gesture to do a certain motion, another gesture to roll a body. And we called this set of gestures a gesture language called MedProc, for medical procedure. And then we backed that up with voice commands that could do some various things. So so this was our contract officer representative to start was Matthew Hackett, and that eventually became Hugh Conacher, and then it's moved on to other people since then. So we wanted to control these simulations using this toolkit. We wanted it to be universal. We wanted it to have medical capabilities, even though you can use it for things besides that. And we wanted to combine voice gestures and other things. So we first universalized and looked at a lot of different sensors and things that are available. When we did that, we're looking at things like Xbox Connect 2.0, which actually was kind of a dead end there, but the technology wasn't. We looked at Intel RealSense. We looked at Leap Motion. We supported the Perception Neuron glove, which is a bit bulky, but works pretty well. And we were anticipating there would be many more gloves and things like that, wearables that you could do. But that never really materialized. Most of the gloves ended up being vaporware. But we built often and we tested often. We learned from our experiences. And we actually made a med product that could do a lot of things and make specific instruments and tools and do a lot of ways that your hand could control a lot of things. And the MedProc was intended to be specific ways to shape your hand to make specific instruments. There was a desire for a high precision mode, but none of these sensors provide high precision, is one of the things we learned. Like, you're not going to do delicate neurosurgeries with your fingers and things like this using these types of sensors because they are fairly approximate, and there's issues of occlusion or a hand being perpendicular to the sensors, like 3D cameras, like the Leap Motion, for example, or even some of these integrated headsets that have integrated sensors in them. So we found that high precision wasn't something you're going to do with this technology. But that really wasn't what we discovered to be the most important thing through our research. So we also looked at optical instrument recognition, where you could pick up objects from the real world and use them virtually. And that actually worked pretty well. There isn't a good toolkit to handle these objects and motions and integrate with the hands, though. And that might be a future project, to be able to integrate things in reality and virtuality with this gesture system. We've done some experiments in it, but it's not a part of the core feature set of Open Medical Gesture. We learned a lot from what type of devices worked well, which ones didn't, but the fundamental concept worked pretty well. I'll show you some videos of this. So this was just a simple experiment for menu and environment control. One of the things that we learned was that you need a lot of vertical surface if you're going to have to press a button in a virtual environment. You want lots of vertical surface. There's more precision going horizontally than there is vertically. So that was one of the big things we learned. And I've seen many interfaces. So this is a gesture to open a menu. It's a Bloom gesture taken from the HoloLens. And when we make big, fat, tall buttons. It's more important to make the buttons tall than fat, is what we've learned. And a lot of devices, like if you look at some of the VR devices, they will use this level of gesture control as far as pressing things with your finger, and they tend not to go beyond that. So this is a pinching motion to affect zoom in the virtual environment. This is a Bloom command again. And you see in a small window there what's being interpreted by the OpenMG system. So you could close menus, we use a drop gesture to close things. So here's some simple zoom commands. And the system is fairly responsive. So, and this probably goes on, and this is using hands, you close fists, and you actually can change and rotate around the environment by using two fists. So that's an environment control gesture. And okay, that's enough of that. So here is trying to use instruments. And one of the things we found by trying to make your finger like a gun to be a syringe or a cut bandage, you notice that there's latency from these gestures. You notice that you have to perform a full gesture 1 or 2 times. Now for 2.0, Chinmay Chinara was our main developer. And he used different machine learning techniques to get a faster interpretation, which is one of the things we realized, because we don't want that long of a lag. This was reliable, but this thing had too much lag for practical use in our opinion. So here when you touch a hand is using the environmental control gestures to rotate a body. Not the prettiest model. Don't know if we're doing limb manipulation here, but you should be able to pick up a body and limb. It's important to put kinematics in a body so that you can only move the limbs in a naturalistic manner. That's one thing we learned. Sorry, skipped ahead here. All right, so this is a leap motion sensor you see in the lower left here. We've learned that putting these sensors on name tags from conferences is the most reliable position. You could put them on a VR display, and the sensors for your hands move where you're looking, and that works well much of the time. But sometimes people keep their hands, they look to the side, and then they lose track of the hands. So generally, your arms don't go out to the side from your chest very much. So we found a chest placement actually generally works the best for things. You could also put the sensor facing up from the table. That doesn't work as well. You could put it on a monitor facing towards the user, and in different orientations. But this chest mount, if you're using an independent sensor from a VR display, works reasonably well. Okay, so this is a fundamentals of laparoscopic surgery rig, and this is an optical interpretation using the sensor to basically the hand is pretending to be a trocar to basically move these pegs or these shapes between the pegs. And I've got a few examples. So here he's using his thumb to open and close the actuator. So you notice, and this is Andrew Leeds, by the way. So you notice he puts his thumb down, and we learned, do we need a specific gesture, or can we just interpret it having the hand open and closed or things like that? And we've learned that more generalistic and open-minded interpretations work best in these settings. So he was able to do one of the tasks there fairly easily with an optical sensor. Okay, so here's Intel RealSense, which is a sensor mounted in front of the monitor. And here you notice he's using a different approach where he's opening and closing his hand. That sensor did not like the fist and thumb as much, although those sensors have improved. So here we were able to do it there. Let's try another sensor. This is a glove, a perception neuron glove. It's really precise for hand tracking. And what's nice about the glove is you could put a real instrument in your hands and have you actually actuate the instrument and this interpret it. So you have that extra level of realism. So you actually feel the device and feel its resistance against you with the trigger. The advantages of gloves is that you never lose track of how the fingers are positioned and what they're actuating. But the disadvantages is their absolute position in space and orientation drifts over time. So optical gets the absolute position and doesn't drift, but sometimes you block part of the hands or the fingers, whereas the gloves never lose track of what the fingers are doing, but the absolute position can go off over time. We found that combining a glove and the optical works best because it's almost infallible at that point. You get a perfect interpretation if you combine both sensor modalities. Here's an Xbox controller trying to do the same task. Notice that you're restricted to one axis at a time movements. It's difficult to combine axes, especially the depth one because you're at an angle. And so you can't use your Z-axis directly because this is at an offset angle. Now, hockey puck style controllers can do this a little bit better but it's not as naturalistic as using hands with optical sensors. Here's a gesture for using a scissors, and you can hear the scissor noise. Sound's important to feedback, we've discovered. So we're just going to cut a ribbon. A bandage, sorry. And those actually, there we go. And you notice that the cut matches the angle of the cut to the bandage. So that was a specific gesture for scissors. This is a moulage over mannequin. So someone's using a mixed reality, a VR headset, but there's a physical mannequin in the room with the user. And we superimpose the virtual image over the mannequin, and you just put your hand down. And what's cool about this is you feel the heartbeat, but you're actually touching the mannequin at the point the sounds generate. And people love this demo, even though it's a very simple one, because it gives you that tactile sensation. It was very effective. So here's an idea of taking a hand into a stethoscope in mixed reality using a chest-mounted leap motion with the HTC Vive. And he made a cupping gesture, turn your hand into the stethoscope. And what's nice about this is you see here that when the sounds are produced when the hand touches the chest. and we got rid of it. We used a bloom gesture to get rid of the stethoscope there.
Rotate view 60 degrees down.
So this is a command interpreter using voice to frame what the system will do.
Select tourniquet.
So the rotary motions tried to turn the tourniquet. Now, I was never satisfied with this demo, and that wouldn't it be better just to grab the tourniquet rod and try to twist it? And that is what approach we took for 2.0, where we could actually twist things around rather than doing these abstracted things. The balls at the joints are targets to grab to be able to move body parts. Here's a perception neuron glove being used to do actuate a syringe. Overall, that worked really well. It was pretty successful. What did we learn from 1.0? Well, some of the things we learned was that the precision of doing these things was less important than, hold on a minute. The precision was less important, and that maybe it wasn't exactly, we have someone we have to admit. Perhaps having people learn a whole set of gestures is not the ideal. And perhaps we want to make these interactions more naturalistic. So what we did in 2.0, we kept the universal hand model. But what we did is we created tools in the Unity game engine, although this could transfer to other game engines as well, to basically say we should be interpreting user intent and assisting the user to do what we're interpreting them wanting to do. And so hence we have 2.0. And are we still tracking the screen? It says medical virtual reality on the screen. Can anybody nod their head if you can see that screen? Okay, good. So what we have here, and this is the GitHub. I'm going to magnify this and probably enlarge this for you. This is the Open Medical Gesture GitHub. And I'm going to copy that to the chat room so that everyone has that URL. Because this is all open source. This is MIT license. Anybody can have this or modify it or do whatever they want to us. Just make sure you credit us, please. I'll show you a few of those. And if the things I'm looking for aren't there, I've got some videos to show you. So what we did was we took objects and made them into smart objects. So we embedded handles onto objects in the 3D world to be able to handle interactions. And so here you see, like the auscultation is you just put a hand somewhere, you can listen to lungs or you can listen to a heart. That's pretty similar to 1.0. Here with a bandage and scissors, if you see what we're doing here, is you see that all you have to do is grab the scissors with your hand. And we put your hand in an optimal position to use the scissors, regardless of what your hand's doing. And if you open and close your fist, it'll actuate the scissors. And it'll follow the orientation of your hand for how to aim the scissors. And if you want to let go, we do that kind of open up your hand gesture and you drop down and open it and the scissors drop. So that's very naturalistic. It's not high precision, it's interpreting. You also notice that even though we can make a smooth motion to open close, we have an open state and a closed state. People felt that that was more responsive than having an analog open and closing of the scissors. So here's a trocar being used for laparoscopic surgery. Here is a syringe. We have syringes that work in an analog fashion as well as a digital fashion. And actually for syringes, the analog press where you closed your fist or move your thumb gradually works best and is interpreted as the most realistic. Down here's a bandage, pull and release. You just pick up a bandage and grab it and pull it. And then you put it onto the body. See how naturalistic that appears? Look at that bandage. Here's a scalpel use. We just pick up a scalpel and your hand handles the orientation and then you can cut surfaces. Although your program has to do the cutting code. Here's an auto injector where you just take off the tip and you apply it. Here's a drawer. A drawer smart object does a push and pull and has a lid so that you have a way to grab things and you can drop things in it. When we demoed this publicly, we had a ball throwing game where we had this test environment where you could press buttons and turn knobs. think I've got that I could show you. Hold on. I think you should probably see that. Um, so we tried using a bat with a real bat in the real world. It worked. Actually, he's not holding the bat very well, is he? It worked okay, and that was integrating an object detection algorithm. It was a little clumsy, and we didn't have an all open source solution, so we didn't include it in the toolkit. But here is a ball throw from a virtual character, and then we did a ball game where you play toss back and forth with a character. We also implemented OpenMG and HoloLens, which has its own sensors, which there's a limited community, there's limited capacity. And to fully implement it, we'd have to offload some of the code to the cloud, unfortunately. The hand tracking was okay, a little bit of latency, but probably wait for a next generation HoloLens to do this better. And that's using toolkits built into the system. Here is using a menu. So you notice we have tall buttons. There's also a hand menu. You can open up your palm and it opens up like a butterfly, kind of like a fan, where you can have a menu that's based on your hand in the program. I want to show you a ball tossing. So there's a fan menu in the hand. That's in the system. We don't use it very much, but it's there. So we're able to interpret gestures like 1.0 does, but we actually just mostly interact with objects now. I wanted to show you, we have a ball. We drop objects onto things. And we have a demo where you actually have a ball in your hands.
Hey there.
That's something you'll see later. Yeah, we have a ball you can toss between your hands. That's really neat. I'm going to have that added to the GitHub page at some point because that's actually kind of a cool thing to be able to see. And I've got, I think I've got this video in Slack. So I'm not going to have time to show you that here. So, but being able to take a ball in your hands and toss it between hands and roll it in your hands and have it drop from one hand to another and roll naturally is a really great experience with Open Medical Gesture. And I'm going to have that added to this page so you could see some of those capabilities. Is there any chance I've got it on my YouTube? Let's see if I'd like to be able to show you this. Let's take a look. Your channel. Videos. I think I probably got it in here somewhere. Bandage rolls, push pull syringe. Here's a baseball. It's a little hard to see because it's from the point of view of a headset. And it's in the code to detect a throw is very good. You can kind of aim your throws, velocity sensitive. So we demoed this at International Meeting of Simulation Healthcare, and it was a popular demo. They asked us to keep it, showing it for a couple more days after the one demo day. And that was a fun one. And let's see if I've got the ball. We learned that simplifying intent's important. And we'll check in here really quick for that ball play. It's not in there. And I guess I won't be able to show you having the bands, but I will have that put up on the GitHub. So that is an overview. So the smart objects actually have code associated with them to interpret how they get handled. So when scissors known is being picked up, it reacts to opening and closing your hands and moves around appropriately. The body's a smart object. The drawer is a smart object. The buttons are smart objects. We have knobs. You can just grab knobs and turn them. You can move sliders. It's fairly naturalistic. And the code to do that's fairly compact. Currently, we're supporting the best support is on the newer Leap Motion devices, the sensors, and also the Oculus something 2. Does anybody remember the name of that Oculus device? It's one of the newer products. It has
The
a
Meta
built
Quest 2.
Quest 2.
yeah, the Quest 2. Yes, that's right. And the Quest 2 sensors, they're not quite as good as in detail as the Leap, but they have a better field of view, so they're less likely to lose your hands, and they seem to be working very well.
Quest
So
3, Quest 3 is coming out the 27th, and I think it's going to be even a little bit better.
right on. And one of the things is new sensors come out, it's not difficult. It takes just a day or two to integrate a new sensor. And the SDK that's on GitHub includes in its documentation, and the documentation's here, actually includes instructions for how to integrate new sensors. So that's part of the package. And so that's something that we've just released to the public, and it's available to anybody. So I encourage people to check it out, read the documentation, read the instructions, and go ahead and play with it. So we have any questions about the Open Medical Gesture System before we move on to some demos from our partners? Okay, so moving on, let's take a look at, I'd like to introduce Sid Banerjee from MetaImmersive Gaming. He could talk to you about his experiences and his team's experience using Open Medical Gesture, and also talk about, he'll be able to show you some of the things that they were able to do with OpenMG in 2 different simulators. Sid, I'm going to mute and give the floor to you. And if you want to, I will make you a co-presenter so that you will be able to share your screen as well.
Thanks, Brett. Can you also please make Rohit the co-presenter, because he has the videos and he's better able to share the videos. Thank you.
That's done.
Yes, I'll thanks, Brett. So yeah, I'll just start by talking a little bit about our experience. So we're an applied gaming company here at MetaImmersive, and Brett and I talked last year, and he spoke to us about the OpenMG project and what we could do with it. So our mandate was to come up with something finished that looked like something that could be commercially used, of course, as a prototype. And so that's what we emphasized, what we've seen with Brett. And honestly, Brett, I hadn't even seen all of these examples before. It seems like there's a lot that could have been done had we had a little more time, but this is very impressive.
And Sid, what were your expectations of how long it would take to integrate this when we were talking about the project? And then what really happened?
No, yeah, good point. So yeah, when we first started talking about this, and we've done a lot of integrations before. So I think the expectation was that the toolkit was going to be sort of a little underdeveloped, and so we would take a little longer to sort of finesse the code, make sure everything was presentable, up to spec. And honestly, for the integration with the Leap, the Meta Quest 2, that was super, super easy. And that went way faster than we had expected. The integration on purpose, there were 2 modalities that we discussed that we'd want to do with Brett. One was the Meta Quest 2, which was a VR headset, and the other was a regular desktop or laptop computer with a Leap motion controller, kind of to test out how do things work in these 2 different on these 2 different devices. And and it was a very interesting experiment. So Brett, to your point, the MetaQuest 2 went really fast, and like you were saying, the integration was really easy, but then it took much longer than we anticipated for the Leap Motion for two reasons. One is in that we were modifying an existing demo, and it had to kind of work from first person point of view as opposed to a third person point of view, because it was no longer a computer simulation, but now more integrated with the OpenMG toolkit. And so that took some time. And also the Leap Motion controllers took a little longer. So that was our overall experience. To the specifics, if anyone's interested, I have our tech team here with Sujit, and he can talk a little bit more about the specific technical issues if anyone has questions. But yeah, I would say, Brett, overall, it probably took us half the time we anticipated it would take on the Leap, and about 60-70% of the time we anticipated on the Leap Motion with the computer.
Very good. Would you like to show us your first demo?
Oh yeah, I think let's start with the Leap Motion one. So Rohit, if you can queue up the surgery demo, I think that's a little bit more demonstrates the product a little better.
Yeah, just
Right. So this was an existing surgery demo that we had. And this was computer-based, like I mentioned earlier, and you would use a keyboard and a mouse to do the simulation earlier. And then, of course, we adapted that to the OpenMG toolkit. Rohit, I think you're ready to start.
Yeah.
And I understand you changed from a third to first person's perspective, which added to your challenge.
Exactly, yeah. So we developed it at first, and so we integrated the OpenMG toolkit, and the integration worked fine. But of course, then the demo didn't look like it was believable and realistic. So we had to sort of, make the modifications to make it work. So, yeah, that's exactly what happened.
All right, let's play it.
Keep going. This is in a sort of a
to provide a greater sense of realism and immersion. Some of the interactions in this simulation rely on the accurate perception of sounds in the environment. Please ensure that you have a working pair of headphones or speakers and the volume is turned up. Hi doctor, welcome to this interactive simulation on management of a multi-trauma patient. Your learning objective for this simulation is to perform damage control surgery to save the life of the patient in the shortest possible time. Our primary care assessment helped us conclude that this patient is in critical condition requiring immediate surgical intervention for two conditions, pneumothorax and hemoperitoneum. The surgical site has been prepped and draped and the patient has been given general anesthesia. The damage control surgery should be finished within 60 to 90 minutes and the patient should be stabilized in the ICU. The patient's breathing is stabilized. He has equal and clear breathing sounds. The patient's blood pressure is still low at 70/50. Patient's oxygen blood saturation seems to be in the normal range. We need to stop the internal bleeding now. Let's start with damage control surgery. Pick up the scalpel by using your index finger and thumb in a pinch gesture.
So we added the instructions along with,
using your index finger and thumb, form a pinching gesture. And then follow the pathway from point A to point B to create an incision in the abdomen. This is a complicated case of multiple abdominal injury. Liver and spleen laceration can lead to hypovolemic shock and cause death if not treated, while bowel perforation can lead to septic shock and death if not treated.
There's enough blood here, Brett, that YouTube has flagged this as only for 18 plus. Can't share the video publicly.
You'll need to utilize these tools to carry out the procedure. You can move your hand to the left and right, but the hand's motion will be limited to the Mayo stand. To pick up the specific tool you require, position your open palm over the tool and grip it by closing your fist around it. Choose the appropriate tool to initiate the procedure. That's correct. Place the suction pipe over the patient's abdomen to clean the blood and bowel leakage. Pick up the next tool to continue. That's not the right tool at this time. Remember, you must use these tools in the correct order. That's correct. Place the abdominal sponges over and under the liver so that they fill the space. Remember that the abdomen must be under tension throughout the procedure. We should not forget to check for any probable bowel perforation. We will have to perform bowel ligation
I think that
before
gives
we
an idea. Can you
with
pause
the
that and
Bocatab.
show the other demo?
Sure, thanks. Yeah. Rohit, can we queue up the next one?
Yeah, sure, sir.
So the next one was developed on the MetaQuest 2. And I don't know if you guys noticed, but there's a little bit of latency in the sort of the resolution of the hand with the leap motion controller. Part of it was the placement, part of it was just how the first generation leap motion controller worked. With the MetaQuest 2, you'll see that there's no visible latency in the hand gestures or any shakiness at all. And I think that's that's just a major improvement over the leap motion sensors. So this is directly captured from a VR headset. So you're going to see some shakiness because, it's a direct
Hey there.
output.
I'm glad you made it okay. The earthquake has hit the city hard, and we need all the help we can get. Be careful of falling debris from these buildings though. Some of them look pretty unstable. Okay, let's get going. Dispatch says that our eye in the sky spotted potential survivors in the area, and it's our job to make sure they're okay. Grab the medical bag near your feet and let's head out. Keep your eyes peeled for any survivors. Looks like we found a potential survivor.
I think one of the things that, because
like he's
when
in
we
pretty
started
bad
the
shape.
project, there was very little time to. Rohit, you can keep playing it. Let's just mute the audio for a little
On
bit.
the medical bag over there.
I can talk over it.
Let's do a physical assessment and check the responsiveness. It doesn't look like he has visible external.
Rohit, can you just mute the audio?
The patient is unresponsive.
Just mute the audio, and you can keep it playing, but just mute the audio. So one of the things is that, when I was noticing all the stuff that we did with the other demos, we would have loved to add some more gestures and animations if we had a little more time on the project. I think we could have made this like the auscultation. Like there are parts of this demo that we would have really liked to improve had we had a little more time, but very sort of impressive with what we were able to do. Rohit, if you can, you can, the audio can
Rise
work
and
again.
fall.
Thanks.
It doesn't look like he's
unmute
breathing.
it. Thanks.
Let's give him 2 rescue breaths. Each breath should be delivered over 1 second and make the chest visibly rise. 2 rescue breaths given. The medical bag should have an AED kit. I think we need to use it immediately. Let's take off the patient's shirt. Get the AED kit out of your bag and set it down over there. Great. Now set it down over there. Each of the
You
2
give some
rescue
guidance the first time you do things, but you also see how you assist the user in all the actions along the way, because you know what their intent is.
Exactly. Yeah. I think that really helped. Like as soon as you tell people what to do, it doesn't take very long to figure out because it's so natural what you're asking them to do. It's just that, they need to know the
Let's try
exact
that.
gesture. And so it worked pretty well when we tried it
Now attach
internally.
the other electrode pad. Great work. You have attached both pads to the right location. Give the AED a moment to evaluate the
Does
heart
this show
rhythm.
pretty much everything, or is there something else you want to show in this video?
I think
Do
that's
not
it. And then you hit the button and you
evaluate
give
heart
them
rhythm.
you operate the defibrillator. Um, you press the ED button.
Staying clear and do not touch the patient. Everyone
I just
clear.
like the fidelity of how
Delivering shocks.
like the Meta Quest 2 sensors work so clearly with the hand. Like you can see everything you're doing.
Shock delivered.
I think that's it. Yeah.
Shock is
Sort of continues on to end the simulation, but I think that's about it. So yeah, I think pretty impressive. And like I said, if we had a little more time, there are parts of this simulation that we would have liked to add more animations and gestures to. But I think overall we really enjoyed the process.
Very good. Thank you very much to both Sid and the whole MetaImmersive team. That was a really nice demonstration to see. Now I'd like to welcome the Geneva and Exonicus team. Who's speaking on behalf of Exonicus today?
Hi,
Is you, Sandis? Hi.
yeah, so specifically myself, quickly context, and Davis will speak about a technical positive experience. It's going to be brief. If I may, to share my screen.
Oh, I will make you a co-host. I forgot about that. Sorry. Make your co-host now.
Yeah. So specifically, quickly, who we are, Exonicus team, focusing on virtual reality trauma simulator. So specifically in this project, we used our MilXDS environment. We do have for a CBRN, tactical combat casualty care, prolonged field care. And so specifically in MilXDS environment, there were a patient, a user, so a combat medic who has to perform certain actions, and a video of the integration we have completed.
That's really nice hand tracking. Is this with the Quest 2?
Yes, Quest 2. And so, Davis, you may speak now.
Yeah, hey guys. So I will give a brief intro
Hey, everyone.
experience.
Oh, if I may interrupt with a quick question, Davis. Chinmay Chinara is the main developer for OpenMG 2.0, and I just wanted to let you know he's entered and joined us. And hello, Chinmay. And we've been looking at the whole road from OpenMG 1.0 to 2.0, and I want to thank you for joining us. Davis, sorry for the interruption. Please proceed.
Yeah. So first of all, when we started the project, we tried both options using Leap Motion and Oculus tracking. So we end up using basically this Oculus 2 hand tracking because it was honestly, it was easier for us as we mostly used our Exonicus Drum Simulator running on the desktop, and we're using Oculus Link for streaming, AirLink. And we're using OpenXR. So it just makes more sense because the leap sensor we should need to plug in the computer, and we're kind of we can't move around that much, and so we want to avoid wires, so we end up with the hand tracking. And honestly, with the Oculus second version 2.0, it actually become way more better. And it was quite good because it recognized the hands when you put them together. So those things was very well. Overall, the implementation went quite quick. We did the implementation, of course, as this is like quite huge project overall, and we have a lot of functionality. And we still needed to add like some sort of this transition layer on our side from this to what we used before, because we used Oculus Quest controllers, all the buttons, everything, all the interactions, movement. So we kind of did create this separate layer so it works with this. But as you see in the video, overall, the picking up objects, using them with our a bit integrated use was quite well. And I was really happy that actually we managed to run it with OpenXR because our simulation backend works with that, so we can better integrated and avoiding using Oculus this Oculus interaction kit. So yeah, that's like a quick brief of how it went with the integration, and we're still working on it also in the background overall, but we're close to finish. And overall, as you see also in video, it tracks quite good.
Thank
So
you,
yeah,
Davis.
if there's some questions, I'm pleased to answer.
Yeah, sure. So how long did it take you to get the initial toolkit working?
Davis?
Yeah, I had some glitch with Zoom, but yeah, I'm back.
Yeah, how from the time you started, you downloaded the toolkit, how quickly were you able to get the toolkit working?
With that, we in our project we have a lot of different settings, and I think that we needed to calibrate together. I think it went I think it was 2 days to get it up and running smoothly. And of course, then creating this extra layer on top so we can implement it with our core system. So that was the largest time we spent just this transition to use it with our system.
Very good. Well, I thank you for that. And to see that in a military grade simulation like that environment was really great to notice. Hey, Chinmay, one of the things we were unable to show earlier was when you're in the experimentation room and you have the balls in your hands, that little that little baseball or tennis ball. Would you be able to share that video really quick, a video of that interaction with the balls really quickly?
Sure. Let me see. Actually, I have entirely new laptop, so I'm really sorry. A lot of things are just here and there. Do we have it on YouTube by any chance?
No, it's one I don't have on YouTube.
And also,
Unfortunately.
I'm really sorry. Actually, even on my Slack is deactivated, so I had it on Slack. So it'll take me some time to actually grab it. It's somewhere in my computer.
I might be able to grab it.
It's definitely on the Slack. I think we had an exchange about the ball.
Yeah, I think oh, I've got it here. So I've got it on Slack. I need to download that video. So let me share my screen. For some reason, it wouldn't let me in Slack before. So now it does. So I'm going to show you that a video of that. Hopefully, is there a way to make this bigger? Yes, there is. So we pick up the ball. And just look how naturalistic that is. That's a physics model built into OpenMG. And if you drop the ball, you can press a button to get a new ball. So that's it. People seem to really enjoy that interaction quite a bit. And I'll stop sharing. Okay, great. And Chinmay, when we go, like something like the Oculus Quest 3 comes out, will that just work with this, or will it require like creating a new interface? And if it does, how long would it take to create something like that?
Okay, so here's the thing. So the way things right now currently works is we have a tracking setup and we have integration setup, right? So the way we do is we we create kind of a top layer on top of the tracking, wherein it takes in kind of the features that are inbuilt inside that new tracking environment, pulls it into an OpenMG kind of a class, and then you take things from there. So the main challenge would be to study Quest 3's tracking environment and what things they have, and then putting it into that same framework that we have. So that would be the major challenge. Once that is covered, and I think that should be, the only time that it's going to take is studying the Quest 3's new environment and how it does the tracking, and then pulling it into our OpenMG framework.
Right.
So that was the main
does
challenge.
that take months or days?
It might take a month because it could be a new kind of new framework and and stuff. So that needs to be studied. That's the major time that might take.
Okay, very good. So it's on it's on GitHub. What would you
Yeah.
like to say about what's on GitHub?
So what I would say is this is completely open source, and it's not just limited to me developing it. Even if you guys, want to use it, maybe improve on it, definitely, please, you're free to do so. It's available to everyone. It's for the community. So that would be my take on this.
Okay.
Just contribute more and more. Let's improve if you want to, definitely keep improving it. That would be my take on the GitHub page.
Very good. Well, I appreciate that. Are there any other questions from the group?
No, just wanted to thank Brett, you, and Chinmay for the collaboration. It was a lot of fun. I think the team learned a lot, and we're looking forward to how natural gestures and this new kind of interface develops. And I think this was a good way to sort of get acquainted with that format, and then I think more and more we're going to start seeing that modality come up.
Absolutely. I mean, definitely, as these sensors integrate into headsets more and more, and this more naturalistic, I'm really surprised that the OEMs aren't supporting gestures very well. Like you notice that Microsoft has very good sensing capabilities with the HoloLens, makes fairly minimal use of gestures, mainly the hand's a pointing device. Apple uses the hand as an analog control and a pointing device, and the others are doing the same, where it really, I think this interpretive and the smart object approach can make any 3D headset in any environment much more immersive when you're dealing with mixed reality and much more naturalistic. One of the experiments that we did that is not in this toolkit was adding unique sounds for each part of the hand to sort of play in the background in stereo. We did an experiment a while back on it. And what we found is what we never did is we never did a study saying would people sort of interpret those sounds automatically as touch, because haptics are expensive and intrusive, and VR headsets are intrusive. You're occluding from the world. You're using a device it's difficult to install things on, and so by making the interaction easier, I think we're going to enable these and we will enable things to do in virtual mixed reality to more people, a wider audience, to handle it more easily with this interpretive approach of your gestures. And I think that goes along with characters that behave and understanding speech and understanding intent through motion and several of the other things. But I think we're going to see more and more of this gesture stuff, whether it's an OpenMG through it or just learning the lessons from OpenMG. I think we're going to see this more and more naturalistic interactions in the future, and that this was sort of a pathfinder to getting there, and also doing it in an open and consistent way. And the technical approach, the key is interpreting intent and also smart objects, embedding objects with ability to interact with hands. That seems to be the winning formula.
I think some kind of a shared protocol, right? I think because there are so many different platforms with the sensing capability, but on the actual gesture side, I think there needs to be a shared language, a protocol for hand movements or gestures. And I think the OpenMG project is such a good, it's a good starter sort of for, like you said, pathfinder for sort of thinking about that, because I think there has to be a shared language of hand gestures that work across devices, whether it's Microsoft or Apple or so on, so that it can be standardized. As soon as it can be standardized, I think you'll start seeing it appear more and more across devices. So I think OpenMG is a good way to think about it. And I hope like other manufacturers actually start picking that up and we see some sort of a standardization at some point in the hand gestures.
Oh, I agree. Cannot agree more. I think, yes, I agree with you. So I think that's a good introduction. My email is talbot@ict.usc.edu. And I'm happy to field any questions from the public offline. And as a matter of fact, I would like to thank the Exonicus and Geneva teams. I would like to thank MetaMersive. I would like to thank the Defense Health Agency and the Soldier Training Technology Center in Orlando. I'd like to thank CDMRP and the original Joint Program Committee 1 that funded us for the first time. And there are many others I'd like to thank for being able to do this, especially those in the Defense Department. This is now open and this is the public. We're handing it off to the public as open source, and feel free, all of you, to do what you will with this. And I hope you do new and innovative things. And I hope you share back with the open medical gesture community, whatever improvements and new devices you integrate or make. So I want to thank you for that. And I will conclude this meeting now. Thank you all and have a wonderful day.
Thanks, everyone.
Thank you, Brad.